Okay, so I'm going to give you a question here that has, it says an absolute value graph has a critical point of 5/3. So I'm going to give you the critical point. And it says if the original graph had a y-intercept of -15, then it says, what's the original equation of this graph? So I got to be able to work backwards. Now I'm going to show you two different ways of doing this. I'm going to do the easiest one first, and then I'm going to do something that sounds, well, you're probably going to look at yourself and go, I don't get it yet. Well, you will actually in Math 20, but you'll actually look at ones like that with a lot more zest in Math 30-1. But I'm going to show it to you anyways, just so that you can get a flavor for this. Okay, so first things first, let's draw this. If you draw this, you'll notice that there is an intersect. It says it has a critical point, that's at 5/3, right there. Then it also has a y-intercept, which is going to be way down here at -15. So in other words, what I'm saying, if you absolute value this, you're going to have a value here, up here of 15, and that's what your graph is going to look like. Okay, so this is the part that was actually flipped to come up to here, right? Okay, that's easy peasy. Now, here's the interesting thing here. We got to develop the equation for this. Well, it's easy because it's built on y equals mx plus b. It's a linear equation. You only have one critical point. If you had two critical points, then you know it's a quadratic and we got to take a different strategy. But I want to know y equals mx plus b using this idea if I can determine the equation from there. Well, absolutely. Here's the y-intercept. That's your b value right off the bat. So y equals to mx minus 15. Oops. Let me rewrite that. Hold on. Okay, let's try that again. Y equals mx minus 15 because minus 15 in fact was our original y-intercept. Okay, that being said, all we got to do now is find m. Well, think about this. To find m is actually quite easy because I'm starting here at -15, and you know that this is the slope, which is the rise over the run. So look, I'm starting, like I said, I'm starting right down here. I'm going to go up 15. So my rise then is up 15. My run then is over 5/3 because these 2 points, this one and this one, have to be on the line. So my rise is 15, my run is 5/3. Figuring this out is actually kind of easy because you know that this is 15 divided by 5/3 or 15 times 3 over 5. Check this out. 5 goes into 15 3 times. 3 times 3 gives you a slope of 9. So your equation is y equals to 9x minus 15, and that's what was absolute valued to give you this v function. Okay, now I promised you I'd show you two different ways of doing this, which is really, really unique. Now, here we go. Let me show you the other way of doing this. I'm going to look at this critical point down here and know that's x equals to 5/3. Now, here's the cool thing about this. Let's solve this thing and go backwards and figure out the original formula. So in other words, what I'm going to do is I'm going to multiply both sides by 3. That's going to get rid of this guy to give me 3x equals to 5. Then I'm going to subtract the 5 from both sides. And check this out. Boom. That's going to give me 3x minus 5 equals to 0. But here's the contributing factor. It is an intersect here of minus 15, not an intersect of minus 5. So what I have to do then in order to figure out how do I get this minus 5 to be a minus 15? Well, multiply both sides by 3. Look what I get. I get 9x minus 15 equals to 0, and check it out. That's my original equation. So this is more of a Math 30-1 kind of equation, and I also showed you kind of a Math 20-1, but you've got a new twist on this particular question, which I think is kind of cool.